Good afternoon, everyone. I will start my slide by apologizing. I flew in just this morning, overnight from North America, so I'm on more than 24 hours without sleep, and I can't tell you how many cups of coffee I've had, so if I start shaking or talking too fast, just let me know. That being said, before I get started, one other thing I'll also mention is there is a set of exercises that go along with this presentation. So if anybody is interested in trying on anything that I'm going to talk about today hands-on, just feel free to grab the exercises. I'll be around for the rest of the conference. You can grab me, ask me questions. My contact information should be somewhere. Feel free to shoot me an email afterwards. Happy to help at any time. Okay? And then second thing to mention about today's presentation is if at any time you have a question, please feel free to raise your hand. I do have a lot of content to get through. There's a really good chance that your question will be answered by a later slide, but nonetheless, feel free to ask anyway. All right, so that's just a quick background about myself. So I'm a software engineer by training. I'm currently working for Philips. Shout out for Philips, this is a hometown. I don't actually have any affiliation with the local side of Philips here. My focus is completely North American at the moment. So I'm happy to meet some local Philips employees, but nonetheless, the other thing you'll also notice in my presentations is talk about SIM and the SIM Hackathon. So SIM is the Society of Imaging Informatics and Medicine, and it's an organization based in North America. A lot of people have heard probably about something like RSNA. So SIM is almost like a parallel organization, but SIM is more community and education oriented. And SIM hosts an annual hackathon, which evangelizes standards like FHIR and DICOMweb. So the exercises and some of the content we're actually going to have today is all made available by SIM. So we thank SIM for that. A lot of these slides were originally developed by my friend, Brad Genru, who originally used to do this session before I took on the torch from him. He is currently a medical imaging alliance manager at NVIDIA. He's served on a number of standards committees with IHE and DICOM, and I've lost track of how many. He is also from a technical background, has actually gone through the hospital life, so he gets it, is what we're trying to say. Some other contributors to the slides here that we thank very quickly, and then we'll get started. So, imaging. What is imaging? It's often easy to overlook imaging, because if you just simply look at a list of FHIR resources, the ones that are imaging related are extremely small compared to the rest of the list. But the reality is imaging is a big chunk of the workflow, and without imaging, a lot of the workflow won't function. If you think about it with your patient hat on, anytime you have a problem, very high chance you're going to be sent for imaging. Whether it's a CAT scan or MRI or X-ray, the end of the day, it's image. But that's the original old school definition of an image, which is a diagnostic image. Think about the imaging use cases that are evolving nowadays, right? So somebody may actually take a camera. So if any of you have been to a skin doctor, you notice they usually capture things with a camera, right? And then you may actually have procedural imaging. So sometimes nowadays, as they perform a procedure, an operation, they're taking images, all right? And then last but not least, the idea of multimedia-based reports. So reports with an image that goes along to show and illustrate that point they're trying to make in the report. Oh, did I lose my connection? Sorry. Animation gone wrong. There we go. So one of the concepts that is now popular in imaging is the concept of enterprise imaging. I'm not going to read through the entire definition here, but the bottom line is the idea of any image being captured in the realm of healthcare is an image that's supposed to be stored and managed properly. And this is some of the things that we're going to cover today. How do you store it? How do you manage it properly? But that's, again, why an image is important, because you could write a report that is as many pages as you want long, but unless you have an image to illustrate the point, it's not worth it, right? Pictures worth 1,000 words. And of course, the other problem with managing images is what happens if you have had your X-ray taken at hospital A, and now you're getting treated at hospital B, and the two don't talk to each other, and now they have to repeat it. So now you're being exposed to radiation, your healthcare is experiencing delays, If you're there with loved ones, the loved ones are probably getting annoyed because this is getting too much, and so on and so forth. So it's very important that images, again, to think of images as not just something that you just capture and you put it aside and it's done. There's a lot more to images. There's a workflow behind it. So if we look at a sample workflow over here, you make it to a hospital or a clinic. The doctor creates an order. Your order is reviewed. Images, the exam is actually performed, so the images are acquired. And then a radiologist somewhere would create a report, and then that report is distributed to your primary care physician, referrals, and so on and so forth. And we talked about some of the newer use cases. So we talked about enterprise imaging. Of course, now patient-centered care is very important. Like we were just at the patient track where we want the patients to have access to their information. That includes images. More often than not, the patients want to take their images, show them to a second doctor for a second opinion. So that's a use case that we want to be able to support as well here. People are now using mobile devices to access these things. And to a lot of you, the novelty of mobile device may not seem very obvious, but as we progress through the presentation and we start about DICOM and the nuances of DICOM, this becomes a bit more obvious, okay? Of course, there's a shift towards putting things in the cloud these days, service-oriented architecture. In the US, you hear a lot about value-based care. It may not necessarily be interesting to a lot of people outside the US, but it's the idea that it's not about just milking money out of the patient. It's now more about justifying what you're ordering for that patient, whether it's exams or medication or care. It all has to be justified. It all has to fit in and make sense. And then, of course, nowadays we have new concepts on the market like artificial intelligence and machine learning. So all these things come back to how you manage your images. What do you do with them? This is where you go into DICOM. So DICOM is a standard for handling, storing, printing, transmitting information. There's actually more to it, but this is just kind of scratching the surface. So DICOM is not just, here's an image, we captured it in DICOM, put it somewhere, forget about it. There's a lot more to DICOM. DICOM handles how images are stored, how they can be transmitted, and then when you have multiple copies of images, if something happens to any of these copies, like an update happens, how do you reconcile all that information? Make sure that everybody is on the same page. So there's a ton more to DICOM than what most people think about. And while we're on the topic, just random fact, even though DICOM was originally developed for medical imaging, it is actually used in some very random domains around the world. One of the domains I've heard of that just made me laugh very hard is airport security. Some of these scanners actually use DICOM, I've been told. I don't know which ones. I don't know if it's all of them or some of them, but apparently it's a thing. But anyway, so the thing with DICOM is, don't think of just your typical black and white X-ray and CAT scans. DICOM is also capable of capturing other things like this. And as you're going to see throughout the presentation, even the use cases for what can be put into DICOM are actually evolving. At some point in the presentation, we're going to talk about real-time video, like live video, which is pretty cool. Let's very quickly figure out the hierarchy here, what things look like. So at the very top, you have a patient, and patient can have a number of studies. Okay, within a study, you have a number of series, and then within each series, come on, clicker. Oh, there we go. It's very stubborn. Within a series, you have instances. Why do you have the hierarchy? Well, the patient part is pretty obvious. The study part is the next obvious thing. So, maybe today, I don't know, you broke your hand or something, or you're having a symptom. So they order a study for you. Within the study are different series. Series could be different things. So, for example, if it's a problem with your hand, they may decide to capture multiple views of your hand, but then maybe capture something else. Okay, so the example of hand maybe wasn't very good. Let's take an example of a CAT scan. They may order a multi-protocol CAT scan, or maybe even multimodality. So like maybe a little bit of a CAT scan with an X-ray or something like that. So each one of these would be a series, and then within the series you have the instances. So taking the example of a hand, your instance could be one view like this, one view, for example, like that, and so on and so forth. If this is a CAT scan, as you know, CAT scan is basically image, 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 image. So you usually end up with anywhere between 200 and several thousand images in one shot. So these are your instances within DICOM. Is this clear so far? Am I talking too fast? Okay, everyone's nodding, which worries me because this is DICOM. You should be asking questions. No, I'm joking. Don't feel pressure to ask questions. Within DICOM, we heard the talk today about the metadata. It's not just the image. Again, DICOM also manages metadata that is attached to the image. In fact, I would say DICOM is even more about the metadata than it is actually about the image. So some attributes of interest is we have a study UID. UID is just simply unique ID. Now, the unique IDs here use a slightly older format than we are used to seeing in FHIR. So it's usually a bunch of numbers separated by dot. Almost looks like an IP address, but a lot longer. You'll capture things like data study, description, who the referring physician was, and then something called the accession number. So accession number is usually identifier, but that's a human readable identifier. It's not always guaranteed to be unique, whereas the first one we saw, the study UID, is always guaranteed to be unique. Of course, guaranteed to be unique within a hospital system. If you look at multiple hospital systems, you may get collisions, and then you figure it out with different methodologies. Within the study, we have our series. So again, each one of them has a unique identifier. Each one has a modality, because remember, a study could have multiple modalities. So modality would be something like X-ray versus CT, which is CAT scan, or MRI, and so on and so forth. Each one of them would have a description. So there's an overall description of what they're trying to sort of look for, and then a description of each individual scan that took place. A number of the series, and then the part that's being scanned, and of course there are even more attributes that you could discover later. For an instance, we have the unique identifier one more time, height and width, and in DICOM jargon it's actually called rows and columns. And then of course you have the position, so this is a numeric position of the exact dimensions within the patient's body where it's taken. So if any of you have seen 3D reconstruction images, can I get like a show of hands? Have anybody seen these? Okay, so that's how these 3D reconstructions can happen. You can actually take DICOM images, and from the metadata, you identify the exact location and the organs that are being scanned. And all the colors and 3D models are actually built from this information. So again, just shows you the amount of information that is stored in DICOM. It's a lot more than just pixels. And then subclass UID is a fancy word for, basically we saw here, study UID, series UID. This is basically the class UID is kind of like the image type, basically, fancy words for type. Like a lot of you who use RESTful interfaces are probably used to seeing something like MIME type. Subclass UID is kind of similar. It's not identical, but it's easy approximation. Okay, so DICOM, or DICOMweb, and FHIR. How do these two play together? Come on, there we go. So at a high level, you've got these different concepts of clinical data. So you've got HL7, right, whether it's V2, V3, or FHIR. And then you have DICOM, and then all kinds of documents, CDA, XDS, and obviously now we have FHIR documents, as I learned just today. But all of these basically make up your health record, okay? FHIR is generally concerned with workflows. So order was placed, order was performed, report came out, so on and so forth. DICOM does perform workflows, but it's very specific to the imaging part of the workflow. So if you think about between an order, when the order was happened and the order being captured, there is a separate workflow that wasn't on that slide, and that workflow is completely handled in the DICOM side of things. So it's generally transparent to HL7. Just a quick shout out, there's a joint work group between the HL7 group and DICOM, which is actually run by MITA. If anybody is interested at all, please feel free to join, contribute. One of the fruits of the work is something that's called FHIRcast. I didn't see a lot of sessions this time around at FHIR DevDays on FHIRcast. but it's basically a newer standard that allows for integration on the front end. So think about it, multiple applications on a PC that need to talk to each other. That's what Firecast is actually trying to solve. So most people, when they think about integrations, they're thinking about back-end integrations, pushing information server to server. This is different. This is actually on the workstation. If you've ever seen a doctor work, they usually have multiple clinical applications open. These applications need to talk to each other so they're all synchronized on the same page. That's what Firecast is doing. Of course, the million-dollar question that I get at a conference like this is, why can't we just put this in FHIR? Like, why couldn't we just store the images in FHIR? A lot of reasons. One of them is, if you think about FHIR itself to begin with, FHIR is a complete reboot of HL7, right? There's no backward compatibility whatsoever between FHIR and V2. You could talk all day long about mapping between V2 or V3 and FHIR, but it's just not the same. Whereas DICOM and the newer version, which is DICOMweb, are 100% backwards compatible. You could then basically take an image that is 30 years old and still crack it open today in a viewer. Sure, the standard has moved on. There might be things in there that are deprecated, but nothing major. It still works. And it's actually very important because if you think about it, images are a very integral part of the record. And images also tend to be generally pretty big. So depending on, of course, which modality was used to perform the study, your images can be anywhere from several tens of megabytes to several gigabytes. So obviously FHIR is not necessarily geared towards storing that much data for an individual study, right? Like take that and multiply it by how many studies a patient goes through in their lifetime, multiply it by how many patients you have in your hospital system, and you've got a huge number of studies and images that need to be stored and managed. The other one I was going to mention, so there's some quick math here, like if you want to get an idea. So 450 petabytes, something you'd be looking at. And of course, the other one is having backwards compatibility here is very important because to run through that much data and translate it from something like a HL7 V2 to FHIR would be a massive task that nobody in their right mind would actually want to go through. So better leave it for DICOM. DICOM is meant to handle these things. Any questions about this before I move on? I hope it makes sense. Yes?
Regarding Firecast from the previous slide.
Sure.
So you said it's actually for intra-application exchange, or?
Yeah.
And why can it be everything you can use for intra-open might also be for external. So you can also go to any third party, let's say, app and say, do something like do some images as do a CT scan.
It's a little different. So let me explain it maybe with a more practical real-life scenario. Generally speaking, when you're exchanging FHIR resources, right? Let's say, for example, you're sending a service order or imaging study or a diagnostic report, right? Like that's information that you're storing, you're persisting. So that's, one server sends it to another one, and then the other one knows what to do with it. It persists it, provides back an ID. The front-end integration workstation is generally, I'm simplifying, but generally speaking, is content synchronization. So if you imagine a radiologist reading studies, they'll usually have typically 3 applications open. There's PACS, which is used to view images and manipulate images. There's the EMR, or RIS, depending on what you have. And then there's usually voice dictation software, which is what you use to dictate reports. One of these applications drives the workflow, meaning one of them is serving, okay, which patient am I doing next? Which study am I reading? And you want the other applications to automatically follow. So if I'm reading your study, all 3 should just open it up. I shouldn't have to keep copying the numbers between 3, search, search, search. That's what Firecast does. Very simplistic example, but I hope that illustrates the picture. Does that make sense?
So you cannot
more than that, but yeah.
So you cannot create a request and wait for a task to be finished.
It's real time.
But then it's actually, if it's FHIR capable and if
we could definitely discuss this in more detail. It's a little bit of a nuance as far as the use case goes, so I understand, like, it may not be very obvious, but at the same time, Firecast, the whole point is inspired by FHIR, so it builds on top of FHIR, but adds a little bit more to solve this specific problem. Because in this case, the applications are talking to each other directly, so the communication is happening on the PC itself, locally, rather than...
Let's say a given protocol and not by some message which you can transfer over the net.
Yes, yeah. Okay, so the intersection between DICOM and FHIR generally happens in the imaging study resource. So revisiting the workflow right here. Come on, clicker. This clicker is very unhappy with me right here. So if we were to translate that workflow, you've got a visit, which leads to an order. Now the protocol side, let's just leave that aside, and then, images are acquired, report is written, and then the report is given away to other people depending on who needs access to it. Oh, there we go. There's more information. I knew there was more information. This clicker is just really not playing nice with me today. Okay, so correlating these to FHIR resources, you have your encounter right here. Service plan, service request, service request care plan, service request, and then the actual procedure that was performed. The diagnostic report is produced, and then the imaging study. Now, the reality is the imaging study was actually created here, but the point of accessing results and images usually comes after the report, because usually images initially are only restricted to people who are qualified to interpret these images, produce a report, and then everybody's given freedom to say, here's a report with the authoritative findings, and then here's some images for your reference. Oh, sorry. The slides are online. You can have them later if you like. So looking at FHIR R4, this is what the current object looks like. You don't need to worry about looking at this right now. We're actually going to dissect it in more information. But remember the hierarchy we talked about. Imaging study has a bunch of series, and then the series have a bunch of instances. So it's a similar hierarchy. That being said, I don't know if every example you're going to find in real life will have all three of these populated. And let's leave performance aside for a moment. In my experience, I've seen the majority go down just to the imaging study level and skip series and instance. Now, hopefully, I've seen the worst and you see better than what I've seen. But if you do see what I see, generally speaking, the assumption here is they give you the imaging study, which is the information you need to know about the study. And then if you need more information about series or instance, they are just simply expecting you to go to the PACS system, talk to it, and get that information that you need. So PACS, for those of you who are uninitiated, is a system that speaks DICOM. Does this make sense? Okay. So let's dissect some of that information. Oh, I guess before we dissect that, this is an example of what it looks like. So here, you could go and search a FHIR server for studies. Now, the example here, of course, is a poor example where we're searching by name. Hopefully you don't do that in real life. But the server responds and says, hey, I have 2 studies for this patient, and provides an endpoint to each one of them, so you can go retrieve them. And then somewhere here, we should get the example back. JSON response. Okay, again, don't worry about reading this, but here's a nice little response. Within the response, let's skip the text. Let's look at the identifier somewhere here. My eyes can't see it. There it is. So this is an identifier here that is a UID. Not sure if it's readable to you, but I do have another slide where it's actually zoomed in. But you see also this a bunch of series. There's some information on the body site. And then within the series, you've got some instances right here. For the record, this example is actually available on the HL7 FHIR website. They have an example right there handy. That's where it comes from. So if we dissect some of this information, in the identifier, you will usually have the DICOM study UID, and you probably will also find the accession number. Again, Accession number is there useful to the end user. That's what you want to show to the end user. But if you want to make any API calls, you definitely want to use the study ID. That's the ultimate way of finding things and being sure that you're getting exactly what you're asking for. It keeps track of the modality, as you can see right here. So CAT scan, MRI, etc. You can reference an encounter if there was one. You can reference your service request, which in DICOM speak is an order. Reading radiologist is the interpreter in here. There could be a reason for your exam. Of course, the subject is the patient, study date, the physician that requested the study. Endpoint tells you where you can actually go get that study from or get more information about it. We'll talk about that in more detail in just a moment. Procedure type, and then of course there's always a description, so just miscellaneous information. Usually the description in real life is describes what the procedure looks like. It would be something like CT scan without contrast, for example. Things that clinicians understand, tech people don't necessarily fully understand what they mean. So we're generally better off talking about procedure code just to be sure here. I'll skim over the series because we're actually running late, but similar idea, attributes that correlate one way or another. I'll skim over the instance. Endpoint is the one we want to see. So the endpoints, these are, you can have as many as you want of these in an imaging study resource, and you can have as many as you want pointing to different things. So if it says DICOM WADO URI, then this is a way for you to retrieve that study. Now that's the classic way, meaning it's the older standard. If it says WADO RS, so the distinction is URI versus RS, then this is the RESTful query. So this is DICOMweb now versus old DICOM. There's Keto RS, which is a RESTful query. So Keto is the one that provides you with additional metadata, but not the actual object, not the full pixel data. Whereas the retrieve gives you the full pixel data. So again, think of a study. If it's a study that's 100 megabytes in size, if you do any of these retrieves, then you're expecting to get 100 megabytes worth of data back and be able to process through this. But if you only need a couple more things that maybe were not stored in the FHIR object, then you want to do the query. You're just saying, give me more attributes. I need just a little bit more information. This is an IHE profile called Invoke Image Display, which basically says, hey, if I have a system and I really don't care for handling DICOM, I just want to be able to give the user a link, send them somewhere where they could see the study and interact with it. That's the one right here. I don't know how many people actually use this in real life, but it is there. I've not seen it. Hopefully you do, but only time will tell. Now that being said, if this is not populated, usually most institutions will have some kind of image viewer where you can basically just open it up in a new tab or a new frame, pass the identifier and be like, here, take over. I don't want to deal with this. Okay, and then of course the URL right here, which is where to go for whatever information that you're looking for, whether you're retrieving, trying to display, trying to get more information. This is the actual URL here. There's an example that correlates it, but I'll skim over. So real use cases. So one of the use cases, say you have an application like an EMR or some kind of patient portal, and you want to be able to show images. There's a simple, may I say, naive example. The reason why I say naive is, remember when I talked about images in DICOM and I said most people tend to think about grayscale images like CAT scan or X-ray. There's a lot more to these images than what people realize. A lot more. For starters, if you compare these images to an image you take with your phone, image you take with your phone is 8 bits. Those images that are captured by these machines usually are 12, sometimes 16 bits. So these images don't just translate to a simple JPEG you could show. They may actually be stored in JPEG format within the DICOM file, but to show them accurately for a clinician to be able to interpret them or make something useful out of them does take specialized tools. So it is available for you. There are means where you could show an image, but make sure that you don't trick yourself into thinking, I could show this image to the person and they'll be able to do whatever they need to do with it. It's more like if you want to show it for convenience, then yeah, go for it. But if you want to show it for any useful purpose, you want to use a proper DICOM viewer, because they need tools, they need to be able to make measurements, they need to be able to adjust contrast, brightness, and things like that to be able to make use of them. If there are multiple images, like a CAT scan, they actually need to be able to loop through them. So they don't need just one individual image at a time, okay? So just a big disclaimer, that's one of the reasons why DICOM exists. It also, one of the things it manages is how you display an image. So a real DICOM viewer reads that metadata and can alter the display of the image accordingly. Thank you.
Do you see, so typically you have lots of FOX viewers that are really, really DICOM native and driven by DICOM. Do you see a growth in the amount of viewers in this space, in the EMR?
There is definitely a big trend, and actually I feel like we're probably at the bottom of the trend. I feel like everybody is now image enabled. So every EMR is now somehow integrated with an image viewer, whether it's embedded or just simply a link that opens up a new browser window or something. It's a very common thing nowadays. Yeah. Now again, the image, like showing an image, all depends 100% on who is your target audience, right? Like think of the example of reading a radiologist on one hand versus your referring physician that is looking at the report and an image. So that referring physician may not necessarily be too concerned about seeing it in a proper viewer, but the radiologist or somebody who is maybe the specialist would want it in a proper viewer. All right, so another one we have is being able to get a thumbnail of the study. So that could be another example where you could request an image and show it, just because maybe you have a client and you want to be able to show useful thumbnails instead of just a plain, boring list. So that could be a useful example. Now, there is more talk about thumbnails, but we'll see if we have time. Here's an example of how you could figure out what kind of call you could make. So in here, we have an imaging study. There is the identifier of the study, and I've made this pretty short just to keep it simple here. They're usually a lot longer than that. And then within the study, you have a series. Within the series, you have the image. Now, the one thing I don't have in this example right here, because it's too long to fit, is the endpoint. So remember we talked about the endpoint attribute? I don't have it. But if you did, sometimes the endpoint may actually give you most of this already available, and then you just fill out the last part. The last part here is the size. So here you're saying 50 by 50 pixels. So I want it scaled down to 50 by 50. This is super useful because, again, remember how we talked about these images being sometimes really huge? These images can sometimes be several megapixels huge. So obviously you don't want to retrieve the whole thing. You could just ask the server to resize it for you and then load whatever size you need. And then, of course, you could specify what format you'd like it in. So JPEG would be one, PNG would be the other, depending on your preference. There's no real advantage for PNG here over JPEG. They're obviously not transparent. PNG is nicer because it's not compressed, but does it really matter? I don't think so. But anyway, so you see this is where these identifiers came from. So they all came from the different attributes that we saw here. And if you look at the exercises that I have attached to the session, it goes into this in more detail. Okay, so there's a little bit of talk about thumbnail here, but I think I'm probably gonna skip. What I will just quickly show you though is something to think about. So this is also one of the challenges that DICOM deals with. You have here a CAT scan, so you can see the progression. They're scanning somebody's head, right? How do you decide that a thumbnail is useful, right? Like, do you just take the first one or do you take the last one? Because the first one and the last one in this case don't really tell the clinician anything useful. Well, the one they're looking for would be somewhere in the middle. Obviously, it's not the fifth one every time. It all depends. So that's why within the DICOM standard, there's now a new amendment to the standard for a thumbnail service where you could say, give me a thumbnail. So you're asking the other system, pick a useful image from this series and give it to me instead of you trying to decide. Okay? I won't go through the other thoughts, but we'll just keep it like this. There's another use case we talked about. So, you've got a report and you want to be able to show some images in the report. So you could, marry a little bit of data from FHIR with a little bit of data from DICOM, and boom, you have a multimedia report. All right, I gotta go a little faster, sorry. There's another dreamy use case that I won't cover right now. And we'll skip this as well, sorry. I would have loved to cover this. Very quickly, a couple of things to think about as well. So I assume most people here know what IHE is. A couple of profiles that might be interesting. The first one is brand new that just came out, encounter-based imaging workflow. Web image capture has been out for a little while now, web image access. So these are profiles just specify how you deal with specific workflows. So, web image capture is literally capture with a mobile device that's got nothing but a web browser, basically, and so on and so forth. Remote radiology reading workflow is one where radiologists could be essentially working from home and be able to still do the work they need to do. Now, it's not so much about working from home, but think about remote areas. I don't know, somebody in the North Pole and the radiologist is far away reading their images. Okay. Similarly, within DICOM, there are interesting developments for anybody that wants to dive really deep into DICOM. So some MIME types have been refactored for how you ask for images. Real-time video just came out. This is very interesting. So real-time video would be like, surgery being performed, and you can actually broadcast it live, not on Facebook, but within the hospital. Just don't get any ideas, people. Thumbnail service, I talked about that very quickly. Some security updates. I mentioned this one just because a lot of people have seen the video on YouTube where somebody went in and plugged the device and hacked a scanner. DICOM has had security built in since day one. The problem is most vendors don't implement it. That's the sad part. So if any of you work for institutions or hospitals, tell your vendors to either support security, and if it is supported, make sure they implement it, because it's supported things like TLS for a very, very long time. One cool thing about DICOM, you can encapsulate anything in DICOM. So one of the newer updates to the standard allows you to encapsulate 3D models for 3D printing. And conclusions, very quickly. So I hope by now you understand what the difference is. So the majority of your workflow is done in FHIR, but when you get to the imaging part, it's DICOM. Obviously, both are standards that are using RESTful interfaces, so modern web architecture. But keep in mind, DICOM stands out because of the fact that it's backwards compatible. So, somebody like a PACS vendor could release a new version of their PACS, which now suddenly supports DICOMweb. The other nifty use case about DICOMweb being backwards compatible is if your PACS vendor doesn't have it, there are open source projects that can give it to you. You can put a piece in front of your PACS, and now suddenly it speaks DICOMweb, which makes it super convenient. So anybody needs DICOMweb today and your vendor doesn't give it to you, you have options. All right. Some websites for more information. So there's the DICOM standard website. There's a cheat sheet that's available online as well. Help yourself. If you just Google DICOM cheat sheet, you'll find this. You can thank Brad for it. He made this cheat sheet. And of course, shout out for the standards bodies. If anybody's passionate about any of this stuff or you have a use case that you feel isn't solved here, feel free to get involved. I think that's it. Let's see. We'll skip that. And again, we thank Sim for providing the server that you're going to use for your exercises. Oh, one thing I should say about the server for exercises. The server uses an API key for authentication. The API key right now is a generic one that is available for the period of this conference. After the conference, you'll have to get your own. That's the bad news. The good news is completely free. They just use it for tracking just to see how many people are using the server and how far do they keep using it down the road. So if anybody needs help getting API key afterwards, just get in touch with me. All right, we've got 1 minute left. Any questions? I'm pretty sure I'm done. Yeah, there you go. It's all done. Any questions? Yeah, please go ahead.
What can you say about DICOM SR, structured reporting?
It sucks. No, I'm joking. No, I'm joking.
Isn't that closer to FHIR?
It is, but DICOM structured reporting is actually, I feel like it may be even older than FHIR, to be honest with you.
Yes.
Now, it is not really conceived, in my opinion, to really author diagnostic reports as much as it's used for computer-generated measurements and things like that. So these days you go in for an ultrasound, the machine might be able to generate a bunch of measurements. And DICOM SR is a very nice format for being able to keep these measurements in a structured way. Does that answer your question?
In part, I was thinking maybe FHIR is a good new alternative for the DICOM SR. That DICOM SR tried to solve, right?
Yes, that you could definitely say that. That being said, the reality to keep in mind is the fact that a lot of these machines have a really long lifespan. I mean, ultrasounds maybe not so much, but the bigger machines like a CAT scanner stay there for 10, 20, maybe even 30 years. So retrofitting them with something modern like FHIR may not be always easy, but retrofitting them with just like a new flavor of DICOM is sometimes a lot easier. Also, it's expensive for the vendors to implement so many different standards on a device when they're trying to keep costs down. So they may just keep it to SR for now, but then somewhere down the road, that information can be copied over to a FHIR object.
Yeah.
So that doesn't stop you from doing that.
From a usability perspective is what I was thinking,
Yes.
not on the device. Yeah.
Yes, exactly.
Clear. Thank you.
No problem.
DICOM workflow, the same question regarding DICOM workflows and the FHIR, which actually should replace, I thought, the workflows in DICOM.
Are we talking like replace imaging altogether?
No, just the workflows, the workflow part, actually.
Oh, the Firecast workflow. Let's do that offline, just so I'm not holding up everybody. So we could talk afterwards. Yes. Okay. Any other questions? Yeah, go ahead.
There is significant overlap in terms of what exists in QDO
Mhm.
as well as the imaging study. So given a choice, what should a developer prefer to use actually?
The ultimate sort of truth here would be keto, for sure. Oh, sorry, my bad. The question was, there is some overlap in the attributes between what you get in imaging study in FHIR versus what you might get from the PACS in the keto request. Which one do you believe? The ultimate sort of truth would be what you get from PACS, but it comes down to the individual attribute. So if it's attributes related to the exam itself, I would trust PACS. But let's say, for example, it would be something like, the reference to which service request it was, then I would trust the FHIR object. Go ahead.
Maybe to pick up on that, usually in PACS, the image when you store it, you cannot alter it. So with QDO RS, actually, if there's mistakes, you might want to correct these mistakes in your medical record, and then they won't be updated on your PACS system if you follow the standard completely. So the most up-to-date data will actually be in the FHIR resources, if I understand correctly.
And I'll repeat it for the sake of the recording. So what Nick was saying, that a lot of PACS systems don't let you alter the study information after it's been processed. So it might be that you can push the updates to FHIR, and then FHIR has the most up-to-date information versus DICOM.
Straight on.
All right. Thanks, everyone. Have a good day.